G'day guys. Well, I went to go out 3 o'clock in the afternoon and I had people come round in the morning, and when they had left it started raining at about lunchtime, and it stopped raining now, and it's just a few minutes past 3 o'clock. The sun is out but the ground is wet, so I'll see if I can still get out probably in about half an hour or so. But I've got the detector. This is this GPX 5000 down there, and if you can notice that I've actually installed the variable gain on the front panel. So we got the variable gain on the front panel, and it's running pretty smooth actually. I think with a lot of the external controls you put on these detectors, you really want to make sure they're all grounded. Everything's commonly grounded. Just stops any entry points for spurious signals to get in and cause noise. The other thing too, which I've done, and this is what I wanted to prove with the variable gain, that at some point in history, someone did say that the variable gain, oh, sorry, now I'm moving this without thinking. Sorry, variable frequency. The variable frequency. The way it was done would cause phase jitter and cause a noisy signal. Well, I've got this set up at the moment. I don't know if you can see the oscilloscope too well, but I've got this thing, it's going as fast as it can. I'm talking about the oscilloscope, and it's looking at part of the signal there. I've got the two reference lines there on the left, and you can see the vertical little bit sloping part of that signal, because this thing is running very fast. I think I've got it on 1 microsecond per division, and I can go higher, but it's really hard to get it to lock. But if you have a look at that there, you can reference that against the vertical from the cursor, and there's no phase jitter whatsoever. It just stays stable, and you'd hear it in the detector anyway. It's just purring like a pussycat. Yeah, to say it in a way. But anyway, this video here, apart from waiting for the ground to dry out a bit in the middle of winter, it's a bit difficult, but I'll give it a go. So someone asked that, or told me that I didn't explain properly or do the visuals on the targets between normal mode and fine gold mode at each extremity of the frequency range, which I'm going to do. And this is the reason I've got the camera elevated at the moment too, because I've got it right up, which means if I turn it slowly here, we're level with the coils. So hopefully, if I go too high, you won't be able to see my hand, but it give you a better idea close up. I'm going to move this near the coil again. I'm going to be careful because I've got this the tripod is right up in the air, and that means the feet are really wide and very easy to trip over it. Let's check this. Yeah, I've got the microphone near the speaker. It is on. I'll just check my one, make sure. Yes, it's on. I just recharged the batteries in the microphones. And yeah, we'll see how this goes. First of all, what we're going to do, how about, for instance, I'm going to put this detector, I'm pointing at the coil, aren't I? You really need a cameraman to do this. So what I'm going to do, I'm going to set this to factory default. So we'll turn it on. Okay. and reset all. So all settings have been reset. So it's factory default with all the controls. And around here, we are in normal timing. Okay, normal timing. It's in mono mode. The reason being because I'm running the anti-phase coil, so I can use mono mode, and it's quite nice and stable. I have got the heater going on here, so we may get a bit of noise when I turn the gain up, but it's freezing. It's really cold. So, okay, that's full gain, full front end gain. This is the gain stage that I've put in there. And it is a little bit rattly because we're picking up a bit of interference. That causes interference. I'll see what I can turn off. I don't want to lose the light. That's the light, I think, isn't it? That one? No, that's the power board. And up there I've got charging equipment. So we'll drop that off just in case it does make, I think most of it's from the heater. So I don't know what I can do about that. Anyway, let's get on to this. I'll set this up at the coils. I didn't want to move it that fast because people tell me they get car sick. But let's get onto it. It's on that. It's on normal. I'll just go down. Manual tune. So at the moment, we're right in the middle at 128. Let's go right up. Okay. It's me touching it as it goes off because the case isn't on, but I can't do much about that. Okay, this is normal mode. Hang on a sec. I just want to look on the computer just to see if they specified target sizes. I'll watch this one through. Still missing the full comparison on normal versus fine gold, on depth versus frequency, high versus low. Okay. Normal versus fine gold. So this is normal. So I might have to zoom this out a bit because I'm pretty close. Now, I've got the oscilloscope probe jammed in like that. The coil is actually picking it up. That's why we had a really good picture on the oscilloscope. But the trouble with that is, if I wiggle anything, it's going to detect it. But anyway, we'll try it now. Normal mode, flat out gain 0.05. I'm going to look here. Maybe I'll zoom out a bit. Otherwise, you won't be able to see. I really should use a ruler as well. I should have that new ruler here somewhere if you want to measure it, but I can't see it. Maybe it's outside. I don't know. But anyway. Okay, that's 0.05. The 0.1. Puts out about there somewhere. It's pretty high above the coil anyway. That's wobbling this. As soon as I touch that slightly, it's going to make a noise because it's got a metal clip on it. But because it's not moving, it shouldn't interfere too much. But if I do wiggle anything, it's going to make noise. It's like a target. So that is where we are. I wish I had a ruler because it's very hard on visuals just to retain that information exactly. But let's go down the lower end of the frequency range. So this is still normal mode, and I was going to spin it all the way down to 0. I'm getting there. 0. Okay. Frequency. The longest pulse well, it's not the longest pulse we can get out of the detector, but those 3 pulses will be just over 40 microseconds long anyway. As you can see, the signal on the tiny gold is diminished. Still get it, but like I say, big pulses for big gold, little pulses for little gold. But things on point one, it's going to still be a pretty decent signal. Even on a low frequency, you're not going to miss a point 1, which is my argument. It's worthwhile digging. It puts out around there somewhere. Around there. So that is normal timings, low frequency. Now I'm going to put it into enhance, and this will be enhanced low frequency. So I'm going to walk around the tripod and get between the chairs. And over here, okay, it's now in special fine gold. 0.05, low frequency. As you can see, the response on fine gold is better than normal timings on a 0.05. Puts out about there, somewhere around about there. A point 1. Somewhere around there. So that's a point 1. Probably get a bit higher, but a little bit of background noise from all the electrical here is causing a bit of an issue. If I put that down, it'll make a noise. No, I didn't wobble it too much. Okay, now I'm going to wind the frequency down and put it, sorry, I'm going to put the frequency up. I'm going to wind it up to 255, so we get very, very short, sharp pulses in fine gold. I know if you spin these too fast, these rotary encoders, they don't change the numbers. You've got to go relatively at a constant speed. Well, I'm up to 143. Right, up you go. $255, finally got there. But like I say, that's giving you 255 frequencies. If you want to look at it as frequencies, you got 255 of them. So anyway, this is fine gold, highest frequency, full gain. Let's see what happens. 0.05. Yeah, there's a little bit too much noise coming in. I know that I can get the signals up here, but it's hard to hear through the noise. You've got to get the timing right. It's got to be between the noise dips. I can still hear the downward dipping signal, but I can't. Yeah, you hear that woo, woo sort of a sound. Yeah, got a bit too much background noise. Really need to be out in the bush doing this. Too much switch mode power supply, electrical computers on, heaters on, which the heater's probably not a really good thing to have on when doing this. Very hard to get noise down, and also it's more or less the middle of the day, and it's very noisy here in the middle of the day. You really have to crank the gain down on what you're working on, just to get rid of the noise. You can't do adjustments and testing with this much rattle going on. So what you'd have to do if you're trying to do improvements on a metal detector, you'd basically just turn the gain down to a certain level till you got rid of the noise. Then you can look at signal levels and compare, apples with apples, not apples with oranges, because it doesn't make any sense. But even high frequency, flat out gain. Let's go and try the old ring. I'll probably run out of room here, but yeah, even way up in the air, a little six odd inch coil. I think it's about 6 inches. I'm way up in the air there. Hang on, got my hands full of test targets. Oh, I'm going higher. Okay, now I'm up here somewhere. If I do big swings, you can hear it more clear because the signal's radiating out in the bigger arc. It's way up there somewhere, but anyway, it's getting it, no worries. Even in that configuration, it's working quite well. Now, you keep loosening things off on this tripod and tightening them up. So, put the ring there. But, as targets get bigger, the depth goes, it gets far greater. But like I say, even at the moment, we're at, well, what I'll try that 0.012, that miniature thing. We'll just see. The noise is really coming up here. Don't know why, but it is. Bit hit or miss, but that little thing there in the blob of hot melt glue, it's acting like a lens, trying to make it look actually bigger than it is, but it's not. It's very, very small. Yep. Away from the noise, you'd hear that pretty easily. But, who wants to dig up tiny little things like that? It's just getting a little bit ridiculous. Well, you can, but I'm not saying it's a bad thing, but I personally would not waste my time on that. Now, with this detector the way it is, now like I said, I've optimized everything so it will not desense. It has a very fast, there goes that, very fast response time. The ground balance is fine, like in the other videos, and yeah, that's Jason. I'll just wait for him to realise that I'm not going to answer just yet while making a video. I turned this into flight mode on the iPhone, but I didn't do anything on the computer, and it's going to ring. So yeah. Yes. Give up. Oh, hang on. What if I hit X here? Bang. I hit X on the iPhone. Ah, there you go. That does it. It turned it off on the computer as well, I think. So let's turn the gain right down. Now, I hope that cleared up a little bit of stuff. Now, this isn't the final version of this detector. Now, I had a little bit more in-depth look at what I've done, and I've had a look at some of the specifications of various components and so forth. And I actually worked out that I've got a signal to noise ratio overall on full gain somewhere in the order of 86 to 90 dB, which is really good, by the way. Now, what I can do, and I'm going to do, I'm going to change the configuration a little bit later on. Not today, but I'll probably do it possibly tomorrow if I don't have too much detectors to work on and whatever. And I'm going to optimize the gain stage and lower what we call intermodulation distortion. Anything to do with IMD, I'm going to work on that, and then I'm going to correlate that with the gain, the clean gain I can get out of this without any distortion or any artifacts in the signal. Also, I've noticed that on this too, on the initial turn on of the input stage, there is a slight amount of gain peaking. And what I'll have to do on that, I want to remove that too, because gain peaking can cause intermodulation distortion products. So we need to look at the gain peaking and then have a look for the whole circuit, and we can have a look at how much distortion we have on the signal. So I'll have to inject a nice clean signal, and I will then out of the cupboard there, which is around here. I don't know if anyone's seen this, probably not, but anyway, around there, get around there, that thing in the cupboard there is a really, really nice low frequency spectrum analyzer. It's a really nice, it's a Hewlett Packard, whatever they call themselves these days. You can't get equipment as good as this anymore. This thing's a bee's knees of low frequency spectrum analyzers. It is really, really good. So yeah, I haven't taken it out for a while, but I'll set that up and I can then have a look at my intermodulation distortion products out of the detector. So we do have some nice test equipment kicking around. Not all of it's in here because it won't fit. So I go back around here to the detector. So I hope some of you guys understand what I'm saying when I say I want to optimize the amplification and everything a lot better than what has been done. And we know what we have to attack. We know where there are little bits of improvement to be had out of these detectors. And this is for all the detectors. If you can get into the modules of the newer detectors, which are all sealed up with resin or some sort of plasticky stuff, then you could do some work on those because, you know, are they optimum? I don't know. Can't get in there. Can't test it. So you're stuck with what you're stuck with. You can do other parts of the detector, but not the input stage. Where these, you've got access to the input stage. That's why I love these detectors, because you can make them work so damn much better. And you know, you've all seen it. There's people who change the frequency on these. There's people who do all sorts of things, and the detectors work better. They just do. They're when they come out, they're just rather generic. You know, it's sort of I don't know. It's I don't know. It's just like a standard motor vehicle. It'll go from A to B. Um, it'll go on most roads. Just don't take it through mud. And don't try and put it on the German autobahn because it won't do those things. And you modify these detectors and you're sort of optimizing it, sort of like it'll now go through mud and you can put it on the autobahn. So that's what it is. It's not, you know, it's not exactly that, but I'm just trying to do a comparison of the spread of performance you can obtain with these older detectors. Not saying that the newer detectors are any way deficient, but we can bring these up to a far better standard. And that's very easy to prove. Just on the sensitivity, the extra depth, better ground balancing, and yeah, we will just persevere on. And yeah, and on this one too, I've done a lot of work. How the setup operation works on this detector, that is vastly improved. You can probably get the coilers and run it up side of a hill and it's not going to make any noise, which it wasn't meant to anyway, but I always found they did. As soon as you change the attack angle of a coil into the Earth's magnetic field, it would go a little bit pear-shaped. And that's easy to prove as well. Just find a bit of ground with a slight hill on it, you know, a little bump in the ground or whatever, something that slopes upwards, and wave your coil up and down it. Probably wave it north-south as well, not east-west. And that will cut the Earth's magnetic field and give a stronger signal off that. Do it east-west, it is basically the same in that plane, but north-south, you're cutting the field or going each way into it, sort of thing. It does react more. So that's that. Now I'll look out the door and see if the weather's cleared up enough. We'll just go around here. You can probably stick it there. You can probably see out the door if I open it. It's not raining, but it's fully overcast. I think I'll just put the case on this detector and run it out. Yeah, I'll get the detector and I'll take it out for a run. So as you can see out there, there's not much sunlight now. It's all overcast, and you can see the road somewhere. Where are we? That's the road there, and you can see it's wet. So can't win. You can't win. I wish I lived up, I don't know, somewhere on the New South Wales Queensland border. The temperature's warmer and it's a bit more stable. Uh, and here it's a bit of a cold hole. Anyway, that's enough waffle on this. I'll attempt to go out. It's just past 3:30. We'll see how we go. And because it's winter, I don't know how much daylight I've got, but I'll give it a go anyway. Catches.